That is taking two functions, a little circle in between, and it means you're trying to find f of g of x. Now these are much easier, thank goodness. If you see it written in the other order, g circle f of x, it means of course in this case g of f of x. Yes, sometimes we'll ask you to compose a function with itself, like this, f circle f, which means f of x. So those are some examples of what a composite means. You're placing something into something. Now, the easy part, we'll be doing that. The hard part, though, is on some of these, is the domain that's allowed on all this. So guys, I'm going to start out with, bear with me, here we go. I'm going to give you a function f of x is equal to, here goes, 2x plus 1 over x minus 1. I'm going to give you another function, g of x, and that is going to be written as x plus 1 over x minus 2. Now, you say, Professor, okay, there's my two functions, and you want me to find some of these things called composites. Now, don't make anything hard out of this. So find, from that given, we'll start out with first this composite, f circle g of x, and we'll get that out of the way. Now, can someone in this clever class tell me, why would Ramsey start out with, we had some of these last week, my first example of a composite of two functions, I named the two functions as rational functions. Those are rational functions. And we just did a lesson on rational functions. Am I going to sketch those? No. But let me point out something real quickly. I'm not going to sketch those, but they are rational functions. Anyone tell me, where is the horizontal asymptote if I were to sketch the black one? Where's the horizontal asymptote located immediately? No, horizontal asymptote. This is a reflection back before the break. Where's the horizontal line asymptote if I were to graph the black one?
-1/2?
Nope.
1?
Nope. Do these match up?
Yeah, they do. It should be 0.
So it should be merely 2 over 1.
2.
It's that ratio of those coefficients, 2 over 1. So your horizontal asymptote immediately, if I should ask you to graph it, is 2. The next one, I'll give you another one here. This is also a rational function. It's a fraction, it's a ratio. Do my degrees match up again here? Yes, both understood to be a 1, or my coefficients understood to be? 1, so 1 over 1 is? 1. So up at 1 would be your horizontal asymptote. Because that would it'd be the easiest one ever. Now, Aiden, I heard you say something. Let's go back to the black one, just out of curiosity. Let's just finish this up. Can anyone tell me where's my vertical asymptote located on the black one? 1. You set that denominator equal to 0 and get 1. That's my vertical on the black one. Where's the vertical on the red one? 2. You set the denominator equal to 0 as we discussed before the break and get 2. So I know where the horizontal is, I know where the vertical is. Can anyone really quickly tell me where is my x-intercept on the black one? -1/2. You just merely set the numerator equal to 0 and solve it. -1/2. Where's my x-intercept if I were to graph it for the red one? -1. You set the numerator equal to 0 and solve it. So I've already picked up that much information from before the break. Y-intercept, you go back on the black one, replace those x's by 0, I think you end up with -1.
Yeah, -1.
Red one, if you replace the x's by 0, you end up with -1/2. So I can pick that up just from before the break. No, Now I'm asking you though, take them and form a composite. In other words, I want first this, which by definition is saying to do this. Take f, use my colors here, of the red one, g of x. And you got this. That's what it means to do. Now, Henry, it means this. Take the red and put it into the f. So guys, you go, take the red function and replace it in the x, and if I go back to the x and do it, and not make a mistake, I have on the f function 2 times, in place of x, you're gonna put the red, which is x plus 1 over x subtract 2. Close that up.
Plus 1.
Plus 1, absolutely. Over
X plus 1.
x plus 1 over x minus 2 again.
Minus 1.
And Lisa says a minus 1. I agree with her 100%. That's the way it looks. You're just placing one function into the other. But then the hard part for some students will be to simplify it. Clean it up. Guys, to clean this one up, I'm going to quickly do it. Help me out here. I'm going to think of this 2 as 2 over 1. So if I multiply these two together, you're going to end up with 2x plus 2.
X plus 2.
Absolutely. Hang on. Over x minus 2.
Mm-hmm.
Still got plus 1. Just taking my time here. You guys will make sure you can see this. On the bottom part, if I jump down to the bottom part, guys, the only thing I see to do now is put these two together with a common denominator.
X minus 2.
Yeah, x minus 2, put these two together. Thank you. So we put these two together since I'm down there. The common denominator of x minus 2 is 1 is like 1 over 1, so I got to put an x minus 2 that's missing here. I want a common denominator. Just cleaned it up. So I'm going to end up with x plus 1, right here, minus x plus 2. Let me step back and make sure all that's correct. And then that would be all over my common denominator, x minus 2. Woo! Just cleaned it up.
Yeah.
Now if I go to my top part, should I also put those two together, which then should be a 1 over 1. Another common denominator, x minus 2. So let's put x minus 2 here. X minus 2 here. Now everything's over the same denominator. All I need to do on the side here to simplify this further, up on top, everything's going to be over x minus 2. Let's see what that is. Well, that's all this together.
2x plus 2 plus x minus 2.
Absolutely. She said it perfectly. It's all this. Combined like terms, I see 3x. The 2's cancel. Got 3x. Bottom part, over x minus 2 again. No problem. And here, put those together, guys. Will the x's cancel? I end up with 1 plus 2 is what, 3?
3 over x.
3 over. That's just simplified.
Yeah.
Now, the strange thing about this one that I brought in, it says to clean this up, it really says 3x over x minus 2 is being divided by 3 over x minus 2. That's what it says.
X
Which-
minus 2 cancel.
Which means 3x over x minus 2 times, you gotta flip this over and do a reciprocal, and you have that. Well, some of these terms cancel. 3's cancel. X minus 2's cancel. Are you kidding? What's left?
X. Wow. Simple. Who would have thought? All that work. And look at my two functions. I put these two together, formed that so-called composite, and all that fell out was a simple, this was a simple one here, at least for the answer, a simple answer of x. Which can happen. Now I've got something else to say though when it does happen. This one came out to be just x. The composite came out to be x when you put the two functions together. Guys, I got to put a little restriction here though. Yeah, I'll take that x. That's That's my composite. Now, how did I form the composite? I place what? I place G into F. Please tell me, is there a restriction on that red function that if I should let X be it, I could not have done what I did? X cannot be what? 2. So to make that, or to consider that, I'll put it right here. Sure, this answer is good, but it cannot be 2. Now, let me see how clever. Some of my students may have seen this before. Can anyone tell me if I form a composite and I get such a simple answer as X, which very rarely do you? Does anyone recall what happens? Or if you've seen these before, if something special happens with the two original functions, if you get an X when you form the composite with these two, they have a special relationship, which is going to take me into 4.2, 4.3 here shortly. Some students may know what word I'm looking for. Lisa?
Do the inverse?
They're inverses of one another. Those two functions are so-called inverses of one another. So first I'm going to point that out. Came out to be an X. And here we go. On the side here, we're talking about something like those two functions, f of x and g of x. And g of x are inverses. Guys, hold on. Now, that's my lesson coming up. What on earth, Professor, is an inverse? If I gave you in elementary school 5 and I asked you what the inverse of 5 is, most students would say -5. If I gave you positive 3/4 and I asked you what's the inverse of a positive 3/4, most students would say -3/4. So what does it mean here that this is the inverse of this?
Swapping out x and y values.
Okay, so it's something else. Something else. That's going to lead me into my lesson I need to go into here shortly. Okay, see hands going up. David.
One function's range is the other function's domain.
Oh, hang on. That's part of my lesson. Thank you. Okay, so I saw another hand going up. Yes.
I was gonna say they're like sort of like one functions that are positive parabola that are all like negative parabola, I guess.
Well, I haven't graphed these yet. Sorta. But David, I heard what you said. Okay, here we go. There's a little lesson on inverses on the side here. What on earth does it mean? Here we go. A little discussion right quickly on inverse functions. Guys, if they are inverses, we have a notation. F superscript -1 of x. Did I get a chance last week to at least show you that? I think I did. Did I? The notation? Now, here we go. To lead into why these two are inverses. If I have a set A to contain these ordered pairs, guys, let me just make up some ordered pairs right quickly. So it looks like that. Like that. There, and I'll try one more. Let's say you have a set of ordered pairs that looks like that. So lead me into the discussion. And they ask you to please form the inverse of this function. In other words, A superscript -1. Does anyone recall from last week, what was that calling for me to do? It's easy. Does anyone recall from last week if they asked you to find the inverse and they had the ordered pairs listed, you merely have to do what to get what they want? I see hands going up. Yes?
Switch the x and y.
You flip. Interchange. Absolutely. You guys want to go through an interchange? So this now becomes 2, -2, 3, -1, 4, 0, 5, 1. That's the inverse.
Now, David, here we go. Now, if I go back to the red, now I ask you, what is its domain? You say, Professor, it's a set of x's. Just list my x's. -2, I'll list them like this. -2, -1, 0, 1. Range of the red, the y values, easily seen, 2, 3, 4, 5. Now jump down to the so-called inverse, when I interchange. Now this is the domain and the range of the blue. The domain, the set of x's for the blue, easily seen, 2, 3, 4, 5. The range, the y values on the blue, easily seen, -2, -1, 0, 1. David, you mentioned earlier, I think we sort of see here, you said, Professor, the domain of the function is equivalent to the range of the inverse. The range of the function is equivalent to the domain of the inverse. Guys, is that what's happening as my domain and range interchange?
Yeah.
We're going to take a look at those two functions. And that's what we're looking at for an inverse. The domain and the range will switch, interchange. Now, let me go back. If I did the composite correctly, I think I did, we got merely an answer of what? X. If you form a composite, you get an X. These two functions that you had to work with back here are called inverses of one another. Now, please tell me. Here goes. Anyone tell me what the domain on the black graph is? Just out of curiosity, what's my domain on the black one? X cannot be 1. David? We'll call this David's theorem here. He says, now, Professor, if you go down to the red one and ask for the range of it, what are you going to say the range of it is?
Well, y cannot be 1.
It's got to match this. That's what we had to conclude over there. Let's go back up to the black. I'm going to stick with the red. Can anyone tell me, let's see if I want to do this right now. Yeah, I guess I do. Whew. Okay, I'm throwing it out there. Can someone tell me what the range of the black graph would be? I'm not going to graph these. Does anyone have an idea what the range of the black graph, which is a rational function, what its range would be? Sort of visualize in your mind what the graph of that rational function looks like, and tell me the range of it. So someone can see what the range might be. Lisa?
So why should that be equal to 2?
Thank you. And Lisa, can you tell the class why you said that?
Because the range of the red function is, I mean, like, the domain of the red function
Let's
is...
go, hang on, oh, I love that. Let's jump down to the domain of the red one. If I'd asked for the domain of the red one, did we say earlier X cannot be 2?
Mhm.
And did we not say over there, the domain of this one should be the range of this one? Is that true? And by the way, just out of curiosity, can someone tell me, here we go, guys, this was the domain here, the range here, the range, domain, range, everything's matching up for me. Lisa, is that what you're talking about?
Yeah.
Wow, I just threw that in there. That's all because of David, you brought it on, you mentioned it. This is a relationship between a function and its inverse, the domain and the range interchange. And I have not graphed this, will not graph these tonight. These are rational functions. Guys, with that said, let me see if I should point out something else. How did I get this answer of X? I placed what into what? I think I placed the red into the black. Was there a restriction on the red? I think we mentioned that earlier. X cannot be what? 2, and I think I pointed that out on the side here just to make sure. This would not happen if you let X be 2. And there's your answer. Now, with that said, I said a lot there.
I want to try something. And let's see my time here with you. Now, this may be on the handout you guys had that I gave you last week on composites and inverses. I brought this one in. Here we go. Okay. Aiden, do you have the handout available right there in front of you?
Yeah.
Okay. Would you please name two functions there that have square roots in them?
Square roots?
Yeah, it's on a different page altogether, not rational functions.
Oh.
This one has the composite functions on it. Just want to make sure I'm working the same one I worked on the handout.
I don't think I have the sheet.
Okay, I got you. I see it right here. Okay, guys, give me two functions. We'll slow down and practice something. Yes.
Oh, I found it.
Okay, found it. Okay, Amy, just tell me,
Yeah.
did I give this, for an example, a function f of x, and its name was
Triangle X?
square root x?
Yeah, square root X.
Okay, square, hang on now. Now, since this might be the last one I work for right now, let me label the other one in red. Aiden, tell me what was the next one?
Square root of 2 minus X.
Beautiful. And here as to find this. First, guys, we find f circle g of x. Now watch carefully on those two functions. Maybe the last one is to do tonight, because I want something else for you guys to do with me later on. What does it mean to do? To form it, we're gonna take f of, and since I'm using colors here, f of g of x. This is the red one. That's what it means. To do that, it says merely place the red into the black. So guys, go back to the black, square root. In place of that x, put the red. It looks strange, you know what. Did I do it correctly? Is that what it's meant to do? Place the red into the black? Did I place the red into the black?
Mm-hmm.
It looks strange, but I did exactly what they said to do. Now, if you got to that point there, I'd give you credit. Some students may say, Professor, you could even call this something else, rename it if you wish. Does anyone think they know what that may look like as just one radical rather than two? Yes,
Is it a cubic root?
not cubic,
Oh, the fourth.
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 the fourth root. It could be written as fourth root 2 minus x. And that is your composite, done. Now, I want its domain. Okay, guys, the domain on this, gotta be careful. How did I form this to begin with? I placed G into F. Was there a restriction on G that I should be aware of, because I could not have done what I did if there's a restriction on G? Guys, go back to G. Its domain would be, you gotta consider 2 minus x must be this. We'll solve this inequality. X is less than or equal to 2. There's my domain on the red one, if I made no mistake. I took this, solve for x for that square root, and we've done those square root domains before, and that's that. Now that's my domain on the red one. By the way, did I place the red into the black? So I better point out this could not be done unless you take into consideration, Professor, the domain here must be, x must be less than or equal to 2. Or you cannot do what you did. Whoa. Now it's turned around. Number 2. Now find G circle F, composite of X. This time it means, let me use my colors here, taking G, the red one, and you're placing inside the black one. It means that. So that means merely take the black, place it in the red. Guys, I'll use the red up here. It's gonna look strange. You're gonna end up with square root, that's the G, 2 subtract, and then put the black in, which is square root X. Please tell me, is that what that means to do? If you place the F into the red, does it look strange? The F into the red. Now, that's my answer. Now, is there a restriction I should be aware of that this would not happen unless I take into consideration a restriction? Guys, I placed the black one. The black one's important here. What is there a restriction on the black?
Not be able to.
Up here, X must be what here for domain? X must be greater than or equal what? 0. I better point out right now, this had better be this. Or this is not gonna work. Wow. I see heads thinking, whoa, professor, from rational functions to now these so-called inverse functions. Now I'm gonna slow down a little bit. I'm gonna try something here. On this one, we just finished up here. I'm gonna try G of F. I'm gonna try a number. In place of X, I'm gonna put a number there. Guys, I'm gonna try 4. Which means G of F of 4. Let's try a number, it would be easier. Find F of 4, go to your function F, and replace X by 4. If I do, what is square root 4? 2. So this says G of 2. So you're not quite finished. That says G of 2, go to the red and put a 2 in. What are you going to end up with if we now go to the red one and put a 2 in?
0.
Square root 0, which is 0. And there's the answer. Wow.
Wait, so that's the other one, the second one, is that our answer?
What's that now?
Like the square root 2 minus square root x?
Yeah, just leave that like this.
Okay.
Yeah, I know it looks strange. Yes? No, guys? Make sense? Woo! Now, should I try another one here? On these composites, we got that. Okay, now, call me here. Can anyone tell me before I leave it, if this is the answer, must all of this underneath that large square root, what must that be? Something about it that we've discussed in class before. What should be true about that part underneath the square root? When I asked you to find the domain and you saw a square root, what did you immediately do to find the domain on any square root?
Should be greater or equal to.
So that 2 minus radical x had better be this. That's true, guys? This right here. All this had better be this, or that large square root will not make any sense. Solve this. Move that 2 over. I see the symbol's going to reverse on me. Guys, I did that quickly. Now, can you tell me what would I do to finish up to get the x?
Be square both sides.
Square both sides. Watch what's going to happen. You're going to end up with x is less or equal to what? 4. Already we said x must be greater than or equal to 0. So we got another restriction. Now, can someone tell me what that domain put together, both of them, would look like? Domain can be expressed as you're going from what? 0 up to what? 4. If you put both these together, you go from 0 up to 4. Wow. Yes? No? I know.
So many details.
There's lots of details on this one. Lots of details on this one. Now, I don't want to overwhelm you. I'm looking at my time here. That clock is correct, isn't it? I hope. Except an hour, they have changed it. I see heads looking like rational functions, Professor, now to this. This is gonna drive me nuts. To form a composite, then tell you what the domain of that composite is, so I will not miss anything here. Hang on, guys, let me see what I've got here. We're gonna do this. Okay. Now, can someone tell me, we got a 0 over here. I was plugging in 4. Suppose I had plugged in 4 into my answers. This is my answer. Would that give me a 0 also?
Yeah.
Square root 4 is what, 2? 2 subtract 2 is 0. Would that give you a 0 also? So you can find it in that final answer there. It's crazy to form a composite. And then crazier is what? The inverses of these things. Okay. Mr. Park. We're going to do something in just a few minutes with the class. We're going to practice with a rational function here shortly. You say, Professor, my goodness, rational function, that's the quiz Wednesday. But we have also discussed what? Inverses, composites, and all that together. My goodness, that's 4.1, 4.2, probably a little taste of 4.3. Together, that's a lot. So we're going to slow down and take a look at together one rational function for a little practice before that quiz takes place. And Mr. Park, I'm happy to help me out here shortly. Before I do that, guys, here we go. And like Lisa says, she used the word details. Professor, there's so many details here. That, you gotta do this, gotta do that, you gotta look at this function, you gotta look at that function. And pretty soon all those details are gonna add up, and there's my time consumed on a problem. Here's the way I'm gonna close down with this, because it is getting a little messy. Okay, here we go. With those two functions given on the side here, we'll stop with this, guys. I'd like to find, if we can, this. G with G. Which means this. G right back into itself. Now if I try to place the G function into the G, here's the G is my red function. Can anyone tell me what on earth is going to look strange as you know what? What on earth might it look like if you take it right back into itself?
So that
The
would
red right back into the red might be, someone tell me.
be square root
Now, hang on now, square root, hang on Lisa, tell me more.
2 minus square root 2 minus x.
Perfect. Perfect. She took the red right back into itself. And that's what that says right there. Lisa, thank you so much. G with G. Now, here we go. We're supposed to find the domain of that crazy thing. Okay, first, to find the domain, and I'm closing out this, guys, just watch carefully, these are hard. I'm gonna say, well, since Lisa gave me a square root, Professor, that means all of that that's underneath that square root must be greater than or equal to 0 for that square root to be defined. So I would take this, all that that's underneath there, and it must be that. That's what we do with square root to begin with. Now when I try to solve this inequality, it may get crazy on me, but we've seen crazy things happen before. I move the 2 over, divide and multiply by negative, reverse my symbol, and then do what here at the end to complete it? What would you suggest at the end? Go for it. Right here.
Square it.
Square both sides. And we'll end up with 2 subtract x is less than or equal to 4. That takes me down there. To finish it up, negative x, let's move that 2 over, subtract it, you get 2. Divide by, or multiply by a negative, reverse your symbol. I've got x is greater than or equal to what? 2. That's not a negative 2. Negative 2. Woo! Yes or no?
Just one question, because, so that's.
Oh, no, I know what you're looking at. We're going there, over there. So far, so good. Oh, this is the last one for tonight. This is enough. Now, you say, Professor, that's beautiful. I like that. I understand what you're doing. But to have gotten this answered, I placed what? G into G. Was there a restriction on G to begin with I should be aware of here? X had to be what for it to be defined? Less than or equal to 2 to begin with, where I could not place G into G. There's a restriction. So I'm going to just place on the side here. You better also point out that this could not happen unless you consider X is less or equal to, what was that over there? 2? I think it was, right here. Was that the restriction on G?
Yeah.
Okay. Now, can someone tell me, both those together, what's my domain on this composite? Bracket negative 2 up to 2 bracket. You get outside that domain, your composite will not exist. Whew. Now I see looks like some concerned looks with all this going on. Let me just try one number outside the domain. Shouldn't work. Outside here, let's get outside here. I'll try 5. 5's not in my domain. It shouldn't work for some reason. But let me go back and see why not. Let me go back and try to find G with G of 5, which means G of 5. It's outside my domain, so it shouldn't work. Guys, G of 5, I go to my function back here and put a 5 in, we got a mistake already. We're going to end up with, replace x by 5. Square root negative 3, which is impossible. That's why if you get outside the domain over there, those numbers are not going to work. Not tried 5. Wow. If there's ever a class, Mr. Park, I'm reflecting back on when I had you. And I know some of those classes that when I had you, you guys were exhausted by the time we finished. This is a class where you should be as fairly exhausted after all this. What did we start out with? We started out with rational functions. And we're going to have practice with this shortly. That's your quiz. Did I do oblique tonight? Did I do crossover point? Hole on the graph? Limit as x is approaching this, limit as x is approaching that? And then all of a sudden I changed it after you got back from the break into what, composites? And then all of a sudden changed it into how to find the inverse of a function. Okay. Guys, am I going to do this for you? I think I am going to do this for you. Mr. Park, I'll need your help. You're going to walk up and down. I'll be trying to walk up and down also to have students try to graph this rational function for me. And they're going to turn it in.
Okay.
They're going to turn, they're going to turn it in. But I want to see what it looks like. We're going to help you though. We're going to definitely help you. Yep, okay, almost many times. Here goes. I brought one in. It's not one crazy. Now, would I be willing to maybe give you maybe an extra or a credit point? Extra credit? 2.
Maybe 3.
3. I said 1, I said 2, now Aiden says 4. We'll try maybe 1 point right now. Guys, here goes. We'll see what you do with it. Sketch this graph for me right quickly. With all details. Here it is.
walk around.
Clean sheet of paper. Put your name on it.